Okay, in this tutorial, let's try. LUCI is basically a communication protocol that is being used by us. Uh, just like TCP, LUCI is also based on TCP, but it has a few advantages. So, to understand its advantages, one is you can give a lot of different kind of message boxes. So, message box ID. So depending on this message box ID, multiple devices can get a response. They can share the message box ID responses. So even if 10 devices are connected together, um, and one device triggers this particular ID, maybe the response goes to all of them together, not just one. So it kind of shares. Well, we're kind of assuming that they're all these devices are connected to the same device. Uh, it could be the EVK or a robot. So one of the advantages is this. Second advantage is that using this particular ID, we can set the kind of function that we want to do. So suppose we want to play with the UART, or we want to play with the GPIOs, or we want to play with the I2C. All of these things can be simultaneously, or in that particular packet we can activate these parts of the functionalities. So this gives you an advantage of using multiple features through a protocol of the messages. We'll talk about how the particular LUCI is structured, but in general, let's first talk about the functionalities. Another functionality, you can do checksums internally. So checksums are basically algorithms to understand if there has been some kind of corrupt data that is coming through Wi-Fi. That could be because of some drops in the binary level, or some particular drops in the packets. Uh, Another functionality is the authentication. So by authentication we mean that some unknown user should not be able to enter the particular Wi-Fi network that we are handling using LUCI. So authentication is also taken care by this. Uh, we won't talk about very in-depth details of authentications and checksums, but we will talk about UART, GPIO, I2C activations using LUCI. Now, just to clarify about this particular scenario where we talked about multiple devices connected to the robot, let's assume that all of these are Android phones. Let's say person 1, person 2, person 3, person 4 all have Android phones, and all of them are connected to the robot. Let's assume they completed the authentication and were allowed to connect to the robot. Now that they're connected, suppose uh, person 1 decides to change the volume. When this change of volume is triggered on the robot, not only will it change its volume, but it will also notify all the other people. That's the beauty of LUCI. We can use this to an advantage, and it also has an architecture, a structure to send these messages to all of them in real time and even synchronized. So we can even use the music which is already synchronized in all the slaves of the robot. We can use this to trigger some kind of actions which make it look like swarm robotics, where there are synchronized actions being played because the music is synchronized thanks to all of this. And with that, it feels like all the robots can trigger together at the same time. All sorts of buffers and delays and latency are already taken care internally inside all of this architecture and this framework. Now, to take an example of how a packet would look like, let's look here. So over here we have the LUCI packet with some sort of structure. So let's see what the structure looks like. So we have 002, the remote ID, and then over here what kind of command do you have. So what we're trying to do is do a write UART packet. So applications could be where we want to sync write to Dynamixel motors, or we can even send it to a microcontroller or something. So now over here we have to set the message box number. Again, this is separated by lower and higher bytes so that there can be more than 255 or 256 message boxes. And then you don't really need to worry about these things right now. Let's just look at over here. So some bytes to represent the LUCI length. So after this particular ninth byte, notice that it starts from 0, so this becomes actually the 10th byte. So after this byte, how many bytes are there in your message box needs to be mentioned using this LUCI length. After that, there could be modes which represent, let's say, write UART or read UART or write I2C, read I2C, things like that. These modes take care of that. So it's 0 for writing on UART. And then there could be the length of internal packets. So there could be multiple packets that could be sent through this. Maybe we want to do write UART and write I2C together. In that case, maybe there's a separate mode. So this document basically shows all of this, and this will be uploaded along with this tutorial. So you have to mention the lengths of your internal packets. In this write UART case, there is just one internal packet, and so packet 0 has a length, but packet 1 has no length. And then there are some internal modes which again can be understood in terms of what we want to do with this internal mode. You can see the other functions. You want to do multi-read, and it's different from single read. So in multi-read the internal mode is 1, but in single read the internal mode is 0. So anyway, you don't have to understand the complete details of this, but it's more important to know just the general structure of what LUCI is. So suppose you wrote the internal mode, and after that we can even mention the baud rate index. So we have a specified array of baud rates that we support, so according to that the baud rate index needs to be set. So all of these are kind of abstracted in the library and need not really require a lot of attention as long as you understand how the library works in general. And then from the 17th byte, that is actually the 18th byte, till the end of the packet, you need to mention the UART packet that you want to write. So here it shows an example where till here you're actually mentioning the baud rate and length and stuff like that, but over here your actual packet begins. If you notice, this is also a packet that usually goes into Dynamixel motors. So you have 255, 255, 254 and so on. So this particular packet also has internal checksum, which will internally be taken care by the motors, but you don't have to worry about this. So this is going to be a packet. This is what you usually write to the motors, and over here once you send this message over LUCI or over TCP basically to the robot, it's going to take care that this message from 255 goes to the motors or goes to the UART output. Similar way, we have options to read and sync read and single write I2C packet, sync write I2C packets, GPIO controls, single read I2C packet, etc., etc. We keep expanding our libraries, so this document will make sure that you are in touch with what's happening internally.